So I'm making this video here to give you a little bit of a visual on what we're talking about when we talk about solutions of systems of equations. So let's take, for instance, two lines that look like this. This is a 2 by 2 system of equations containing these two equations here. They're going to intersect at one point here, and this is your solution. So a 2 by 2 system that has one solution can be represented as two lines with one intersection point. Then we could have the case where you've got two lines that are parallel, so they have different y-intercepts, but the same slope. So these two lines never intersect. So this is the case. These two lines would be an example of a 2 by 2 system that had no solution. And then you could have the case where you've got two lines that appear to be different, this brown one and this blue one, but when you plot them, they actually lie in the same place. So they're just like, look at this line here. This is, if I divided each of these terms by 2, I would have these same numbers here. So this is actually the same line as this one. So when you plot them, they're going to have infinitely many dots that they share. So this is the case of infinitely many solutions. So now let's move to 3 dimensions here. So if I rotate my plane, so you can see that this gray flat plane could be like a tabletop or something like that. And then directly perpendicular to the tabletop, this could be your z-axis, so x, y, and z. All right, so these are your 3 dimensions. So if I plotted some planes, all right, so planes are going to be represented in 3 coordinates, so 3 dimensions. So let's take a look at 3 planes here. Let's get rid of that tabletop and the axes so it's not so much stuff to look at. So I've got 3 planes here, and I want to show you that they intersect in one place. All right, so the one place that they intersect is right there. All right, and this is the case where you have one solution when 3 planes intersect at one point, and a point in 3D space is an ordered triple, x comma y comma z comma. Okay, so then we could take a look at 3 more planes here. All right, and these planes, if we rotate it, we can see that they intersect, purple and brown intersect in a line, and then also reddish and brown intersect in a line, and then gray and reddish intersect in a line. But in no place do they all 3 intersect. So this would be the case where we had no solutions, because in order for it to be a solution to this 3 by 3 system, there has to be at least one point that they all share. So this is your no solution case. All right, and then the last case would be represented by these 3 planes. And if I rotate it correctly, you can kind of see there that they intersect in one line. They all 3 share that one line. All right, so anywhere along that line, you're going to have a point that all 3 planes have in common. All right, so this is the case where you've got infinitely many solutions, because along this line there are infinitely many dots. So you have to use your imagination to imagine that these planes go on and on to infinity in all directions. They extend outward on each of these sides to infinity, on these edges. All right, so those are the 3 possibilities for 3 by 3 systems of equations. All right, so that's basically what I wanted to show you. I just wanted to give you a visual for what we're dealing with when we're talking about systems of equations, 2 by 2 or 3 by 3. Of course, if you get to 4 by 4 or larger systems of equations, there isn't a visual parallel that we can come up with, because our senses are limited to seeing in 3 dimensions.